Hi and welcome to this video of nPro. In this video I will show you how you can simulate PVT collectors with geothermal sources. So let's dive into it and let's create a new project. I will select Energy Hub as a project type. And then we have a heat demand in this simulation. We have a cooling demand and an electricity demand. I will deactivate the electricity demand here because it's not really relevant for the simulation. I will also deactivate the photovoltaic because we want to go with the PVT collectors. And I will then go into the settings of the geothermal sources. So the geothermal probes can heat and cool. That's important, of course. And we have a heat pump, a central heat pump, which boosts us the temperature from the 4 degrees Celsius from the extraction temperature to the temperature of the heat demand. And on the right-hand side, we will activate the regeneration. So we will say that the amount of heat that we extract from the ground is the same as the amount that we insert into the ground, that we re-inject into the ground. And that means that we have a full regeneration here. I click on OK. And then we go to the PVT collectors. And we have quite a wide range of settings here. So we can define the area, the collector area, the orientation of the collectors. We can also specify multiple orientations and specify the parameters of the modules. So feel free to play around with it. I will now activate here on the left-hand side the heat generation for regeneration. And I will deactivate the low temperature heat. If I click on Visualize Profiles, we get the heat generation here with an annual profile, as well as the electricity generation from the PVT collector. And here we see that we now have this light blue arrow or line, which indicates that we have regeneration. So we have a cooling demand, and the geothermal source will cover the cooling demand, but there's also possibility to regenerate the geothermal field with the PVT collector. So let's simulate this system. I will click on Size Technologies, and then we will see what's the optimal sizing of the technologies. So we have the PVT collectors here with around about 400 square meters, and the geothermal probes with a capacity of almost 1 megawatt. In the second step, I can click on system operation simulation to see on an hourly basis how is the system operated and which energy flows do we have over the full year. And the first graph will show the energy flows on an annual basis. And here we see that the geothermal probes are covering the heat demand, of course, and also covering the cooling demands. But we also have some small amount of regeneration here. If we go to the winter season, we see that it's predominantly heating mode. And if we go to the summer, for example, then we have a lot of cooling demand covered by the geothermal probes and also this regeneration path. On the bottom, we can create some more plots, for example, the cooling balance. And here we can see when do we actually regenerate the geothermal field. So the light red color indicates the heat for the regeneration. The gray color indicates the cooling demand, and the red is the cooling power from the geothermal probes. And for the electricity balance, we can see that in summer, the electricity demand is covered almost completely by the PVT collectors. And in winter, we need to import quite a large amount of electricity to cover the electricity demands of the heat pumps, for example. I will now go to the result page because I would like to create a second scenario. We would like to compare this PVT solution with a PV solution. So let's click on duplicate current scenario. And then I will open up the scenario number 2 that we just created. And I will, let's call it PV. And now I will disable the PVT collector and integrate photovoltaic. And I will also activate the air source heat pump because actually we need a second generation unit because the cooling demand is lower than the heating demand. So we would not be able to cover the full load or the demands with the geothermal probes. So we need another, if we want full regeneration, so we need another component here. We could also integrate solar thermal, but I think due to the costs, it will not install solar thermal. So let's click on size technologies to see what's the cost optimal solution. And here we see that PV is actually installed, 600 square meters. Solar thermal is not installed. That's often the case, but it's, yeah, at least for projects in Germany and we see predefined costs, but of course we can change the investment costs or change the efficiencies, for example, and then solar thermal can also be built. We have the air source heat pump and the geothermal probes here. And then let's have a look how the system operation looks. So that's always the second step after the sizing to see, okay, what are the energy balances, what are the energy flows, and what are the important KPIs of the system. Normally the second step takes a little bit longer than the first one, yes. And here we can see, yeah, the heat demand is now also covered by the air source heat pump and smaller part by the geothermal probes. So let's go to the result page again and let's compare the two scenarios, the PVT scenario and the PV scenario. I will say load scenario. And here we have now the scenario number 1, which was the PVT scenario, and the PV scenario. We see the CO2 emissions on the x-axis and the total annualized costs on the y-axis. And here we have multiple plots and tables to analyze what are the differences between scenarios, and all the numeric values of the simulation are compared with each other. All right, thank you very much for your attention. I hope it helped you a little bit to understand how to use PVT in such a simulation in nPro. If you have questions, please comment under the video. Yeah, see you next time.